Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Akram bin Adbullah with student ID of 2023-830-382. I am under supervision of Sir HAJI HELMISYAH bin AHMAD JALALUDIN. Today, I will be discussing regarding my final year project titled The Development of Test Rate of Various Exhaust Tailpipe for Gasoline Engine Testbed. This slide will consist of 3 parts excluding the references, where first chapter will discussing about introduction, followed by chapter 2 of literature review, and lastly the methodology. First the chapter 1, the introduction. This chapter will divide it into 4 parts, which is the problem statements, objective, scope of work, and benefit of study. First, air pollution is a major issue globally. The use of internal combustion engine further increases the impact. It needs to be controlled to ensure the sustainability of the environment by reducing the emission released by the vehicle. As we know, in 2025, the issue of air pollution remains highly relevant, as this is driven by activities such as manufacturing, food production, and transportation, which is the focus of this study. So, why we need to control the vehicle-related air pollution? Because vehicle emit toxic gases like carbon monoxide and nitrogen oxide (NOx), which is harmful to our respiratory system as well as the balance of ecosystem. On top of that, the vehicle also release the carbon dioxide gas, which is the greenhouse gases that would cause global temperature to rise, which related to the increased rate of global climate changes. Most all vehicles, in order to reduce emission, they need an ideal operating temperature to work effectively. Tailpipe design impact the exhaust flow and EGT value and need to be optimized. So, the use of an optimized tailpipe design may cause the flow restriction, thus leading to either heat loss or excessive pressure. This could prevent the catalyst converter from reaching its ideal operating temperature. This study focused on creating a test rate capable of testing a wide range of tailpipe in order to help in understanding the tailpipe design effect towards EGT value, as well as the relationship between EGT and emissions. Next is the problem statement, where the first one is there is no dedicated test rate available that accurately measure exhaust temperature across various tailpipe design, limiting the experimental analysis of exhaust system performance. The test rate industry are usually designed to configure one specific exhaust system design, thus can be changed into different design with ease. Next, there is a lack of dedicated test rate that is both affordable to fabricate and maintain, as well as safe to operate during tailpipe EGT testing. The usual test rate, especially the high-end one, is expensive and require months to build. On top of that, it's usually require operator to be in a dedicated control room, which further increase the cost. Lastly, the influence of tailpipe geometry on EGT value is not well documented, even though EGT directly affect the catalyst converter activation and emission reduction efficiency. This is because there is a lack of data that comparing different tailpipe design under similar conditions. The objective of this study is to first design and fabricate a modular test rig that allow for safe and reliable EGT measurement for various tailpipe design. Second is to explore the correlation between EGT and emission behavior, and lastly to investigate the effect of different tailpipe parameters on EGT values. On the other hand, the scope of work consists of 3 points, which is the design and development, which is to create multiple sketches based on customer requirement to determine as well as determine material and component to be used in the prototype. Second is to evaluate the sketches using multiple methods based on the customer requirement, fabricability and financial constraint. And lastly, to conduct a thorough research on the February study involving the EGTs, method of measurement and the effect of tailpipe and environmental. Hopefully, by the end of the studies, is able to first create an adaptable test rate to measure GT, where it could accommodate a range of tailpipe parameters and different configuration while ensuring accuracy and safety of users. Second, it helps designing the optimized tailpipe. This is where the engineer is able to determine the best tailpipe design which balance the performance and emission. And lastly, hopefully it also can help in reducing the emission, where it's the optimized tailpipe maintain the best operating temperature for the catalytic converter, thus improving its performance, thus reducing the harmful gas release. Next, in the chapter 2, we'll be focusing on the literature review. Firstly, the internal combustion engine produce power using fuel through combustion cycle. This cycle is the suction, compression, ignition and exhaust release. Firstly, the air fuel mixture are sucked into the combustion chamber. Then, the piston will move upward, compressing the mixture. After that, the spark plug will ignite, thus causing the mixture to combust. This causes the piston to push downward, generating power. After that, the engine valve will open, and piston will move upward, pushing the exhaust gas out. Internal combustion engine usually have an average efficiency of 30%, where incomplete combustion occur. Incomplete combustion means all hydrocarbons are not fully ignited, generating harmful gases like carbon monoxide and nitrogen dioxide, as well as unburned hydrocarbon. In 2020 alone, the world emitted around 37 billion metric tons of carbon dioxide, with 30% of it coming from oil use. Moving forward, the catalytic converter role are to accelerate the redox process of converting the harmful gases such as carbon monoxide and nitrogen dioxide to carbon dioxide and nitrogen gases. It consists of honeycomb structure made from precious metals such as platinum, palladium and rhodium. These structures are to increase the surface area for a higher chance of chemical reaction. The catalytic usually require high temperature to operate effectively. This temperature start from 200 degrees Celsius and the optimal operating temperature are around 400 to 600 degrees Celsius. Currently, regulation mandate the use of catalytic converter on ICE vehicle, where this is start on the 70s in America with the US Clean Air. The Malaysia followed suit on 2007 with the Euro 2 regulations that mandate all new petrol vehicles to have the catalytic converter installed. Lastly, the exhaust temperature sensor. The changes in exhaust gas temperature are measured using the thermal sensor, commonly the thermocouple. The type K thermocouple are widely used in exhaust system due to its high heat resistance and wide temperature range. This range from negative 200 to 870 degrees Celsius. The type K are made from two dissimilar metal, which is chromel, nickel chromium alloy, and alumel, the nickel aluminium alloy. Is operate on the Seebeck effect, where the temperature difference between two metals produce a thermoelectric voltage. The exhaust temperature sensor help engineers understand how tailpipe design influence exhaust gas flow as well as its temperature. In the last chapter, the methodology, it will be divided into 9 different sections. Firstly, the flowchart, the user survey, house of quality, methodology, plug chart, configuration design, engineering analysis, technical drawing, and finally the Gantt chart. First is the flowchart. This chart starts with the problem statement, where as it's already mentioned earlier. Next is the concept generation, where 3 different sketches are generated using the methodology table. Then In the concept evaluation and selection, using the plot method, those three sketches are then compared and evaluated before the best design are chosen. In the product architecture, it's highlight the product core, structure, and as well as functions. Then it's followed by parametric design as well as configuration design. In the configuration design, decisions are made to either purchase of fabricate component used in the prototype. This then followed by detailed design where it contain the detailed drawings which include the product dimensions as well as profile. This detailed design then are sent for approval where if it doesn't meet the satisfaction, then it will be updated based on the comment given, and this process will repeat until the design given approval. After that, the fabrication process will start following the detailed design earlier. After that, the prototype will be tested before finally for the report submissions. Next is the imported criteria survey, where the pie chart show 5 different criteria, which is the safety, reliability, adaptability, quick install, and portability. Leading with 27% is the safety, followed by the adaptability, which is around 20%, then the 20% for reliability, 80% for portability, and finally with only 9% the quick install. Moving on is the house of quality, where it show a comparison between customer requirement and functional requirement. It shows that with the relative weight of 29%, the client adjustment is important as is aligned with the customer requirement of reliability, adaptability, and quick install. The methodology table show 4 different sub-functions, which is the clamp, mount lock, heat shield, and sensor. In the clamp, there is option 1 is the spring clamp, while the option 2 is threaded clamp. The threaded clamp is similar to the table clamp. Next, in the mount lock, we have the option of center pin and bottom pin. Well, in the heat shield, we have 2 different designs. In the option 1 is the circular cage, while the option 2 is the box cage. Lastly, we have 2 different sensors, which is the thermistor and thermocouple. Next is the plot chart. As there is no similar product in the market, pipe vise is used as the datum for the evaluation. In the evaluation, it's compared 3 different sketches, where the concept 1 primarily use option 1, while option 2 is a mixture of option 1 and option 2, where instead of using a spring clamp and thermistor, it use a threaded clamp and thermocouple. Option 3 on the other hand is primarily using the option 2. Through the evaluation, it shows that option 3 the concept 3 is the best concept and will be the baseline for the final drawing. Moving on to the configuration design, where as mentioned earlier is where the components are decided whether to fabricate or purchase. A total of 15 components are used in the prototype, where 11 of it will be fabricated and only the remaining 3 will be purchased. Next is the method of fabrication for the 11 total component. First step is to measuring, where it's marking the desired dimension before cutting using measuring tool and vernier caliper. Next is the cutting process, where it's to acquire the desired sizing and remove the unwanted part. The tools are used grinder and saw. The third one is the welding, where it's a process for joining metal parts together to create a complete component. The chosen equipment are the gas metal arc welding, or simply called GMAW. Fourth is the threading, where is to create a thread surface on the cylinder of surface to obtain a fastening. The tool I use the lathe machine. Finally, is the finishing, where is to obtain a clean surface finishing for not only for the aesthetic look but also for the safety. The tool used are the grinder and the polisher. Next is the engineering analysis, where it focusing on two concepts, which is the stress and heat loss. The stress analysis is to determine the strength of component in the prototype during the operations. The formula is the sigma equal to F over A in the unit of Pascal, while heat loss is to determine the amount of heat lost to the surrounding due to convections, which will impact the performance of the sensors. The formula is Q, which is the heat loss, equal to H, which is the convection heat transfer coefficient, A, the surface area through the which the heat is transferred, Ts is the surface temperature of the object, which is the tailpipe, and the T infinite is the ambient temperature. Last before the list is the technical drawing, where firstly is the detailed drawing of the full prototype, and it has the width of 1070.8 millimeters with a length of 2000 millimeters and the height of 141.2 millimeters. Next is the assembly drawing. It has 4 different components. Where the number 1 is the base of the product. Second is the second and third is all the mount. Fourth is the heat shield, the box shape heat shield. Fifth is the trolley wheel, and lastly is the product itself, the curved pipe. Next is the exploited view, where it shows where each component are attached to the product. Next is the detailed drawing of the threaded clamp mount, where it have the dimension length of 190 millimeters, the height of 285, and the width of 50 millimeters. Is also included. That is the isometric drawing for the clamp. The last but not the least is the detailed drawing for the heat shield, the half of the one part of the heat shield, where it has the length of 1988 millimeters with the width of 528.4 millimeters and the height of 312.4 millimeters. Last but not least is the Gantt chart, where its role is to plan the FYP progression, while also ensuring that it will be completed within the time limit. The yellow part is the planning, while the actual one is the green part. It starts from the week 1 of the SEM all the way to last week of the next SEM. So in conclusion, the project is to develop and fabricate an adaptable test rig for testing different tailpipe design, as well as to study its impacts on AGT value and emissions. By the end of this project, I hope that the development of the test rig will be successful in achieving its objectives in its journey to reduce the global emissions. Thank you for watching.